So first we'll define what is the amplifier. It's a device that increases the amplitude of signal. Okay, this is basically idea of this one. Then how to construct that amplifier? The same transistor only. Again, what was our requirement for the transistor to be used as an amplifier? What is the basic requirement? It should be used in active region. It should be used in active region. So active region in the sense base emitter junction forward bias and collector base junction should be reverse bias here. So first it should be. Then I'm going to apply the signal which has to be O strength should be increased here. So what is the circuit? The circuit goes on like this here. Again stick on to the same thing. What earlier we did, no? CE characteristic, the same thing. Common emitter amplifier is what our syllabus is there. So there's the emitter, there's a base, and there's a collector. Now, what is the type of transistor I picked up? PNP, or so like a NPN, sorry. NPN transistor. Then the base emitter should be forward bias. To forward bias, what all I needed? So I'm going for constructing of circuit. A battery, RB, then a cell. This, if you want to put, you can hurt it or you can leave it like this. No, doesn't matter. So this particular signal is called as VBB. So what this will do, base emitter junction is forward biased because of this cell and this, and why this resistor, it will protect the diode from higher voltages. Then after this, we'll go for the next circuit, and this is RC. You can what is the difference? This will become a cell. If a group of cells, this will become a battery. So this will be RC. This is VCC. And what is this? The positive terminal connected to N type. Now you can ask questions like you said collector base junction should be reverse bias. This negative terminal should be connected to base. Here, look at the collector base junction. What we have is, what is the trick here? The trick here is base is P type, collector is N type. No, if I make N type more positive than the P type, it will become reverse bias. Can you remember? If this is say 1 volt and this is say like a 0.3 volt, will it be reverse bias or forward bias? Will be reverse bias, no? The same thing is happening. I'll see that the VCC will be greater than VBB. This will be of order 0 to 2 volt. This will be of order 0 to 20 volt. So definitely, so what will happen to the collector base junction will be reverse bias. So like that, the values of RC, VCC, VBB, RB are so adjusted that first these conditions will be satisfied. Got the idea? So already morning we have discussed, no, the same thing I'm continuing here. Now what is the next? So finally what happened, where it is in active region. I personally, I'll check it. I'll see that when I go and check it, no, like a VC is greater than VB. So collector is more positive than base, means N is more positive than P type, then it will be reverse bias. And I'll go and check it. This junction is forward biased. And what is another thing? It should be operated in active region. Active region in the sense, like a VCC is how much, say let's take, I'll take 20 volt. Then what should be the value of VC? It should be of at least half of this one, no? For to be in active region. Like that, what happened? I adjusted and I brought this transistor in active region. Now I am going to apply an AC signal. So what is the AC signal? I'll put a red color here. The signal which has to be amplified. I'll supply it here. This is a V in, and this is VBB. The signal which has to be amplified will get like this. So this is a very small signal. Okay, let's write the uh, expression for all the things that one. So this particular thing will be VC, no? And what about this? This particular voltage drop will be VB. Timing, let me indicate here. So what are the currents? Again, apply KCL. By applying KCL, what we can say, first get the direction of emitter current, IE, then IB. This is IC. Give polarities like this. This will be positive, negative, because this will be, again, don't think that, see, a lot of confusion. So this, what current here? Here is IE. Here how much current? IC. Here is IB. IB plus IC will become IE. Try to understand here now. It's like a junction. This is like a junction. IC plus IB is equal to IE. Okay, got this. Don't think more. I'm telling this one, you need not to do any research here because you have to spend a lot of time. Nothing is there. Nothing big. If you spend some 20, 30 hours, no, it'll be easy, but that much of time not available. So your level, the syllabus or the exams, what you are writing, what all I'm telling is more than enough. Okay, don't type in Google. If you want to type in Google, you see that you'll be taken to somewhere far away. You'll not understand anything, that one. Because the only thing is you have to spend lot of time. Slowly you have to analyze one by step. You have to come in order. I'm putting it in a very simplified way. Just follow the instructions and do numericals. After doing numericals, everything, then you can explore the subject. But don't go for random. This will really trouble you a lot like anything. So here, what is the KCL says? IC plus IB is equal to IE. Okay, let's write the equation. So what is our, where is the output now? This is what output. This VC is what output here. And what is V in? V in is input. For your understanding purpose, I'll write V naught. Clear? I'm going to correct here because this is the output section. This is the input section. I applied it. This has to be amplified. Okay, let's write KVL. Now, what is the KVL? Plus V in plus V in plus VBB minus IBRB minus IBRF minus VB equal to 0. I am bringing so many things here. From where this RF has come, the forward resistance. So most of you get confused. I'll give one small help for you. From where this equation has come. Just follow it. So there's a base, no? So the base, shall I show it like this? No, this is P type, no? P type. There's a base. There's a N type. This was the circuit. Are you seeing any junction? As base emitter junction. This is, and this junction will offer some resistance, no, to the flow of current. Can you remember? I used to say forward current. And what about IB? The current IB has to flow like this. But here, how much IE will flow? This what will trouble you, sir. What is this? If I draw like this, you will be in a big trouble, sir. Like this is a loop. What current flows? The same current should flow. No. Here. Look at this one. That's why the books they avoided. So the same current IB should flow. No, not like that. Think here. This is what I'm extending. Some current will get added up here. I'm not showing it. Some current will get added up. So therefore, a part of circuit showing like this is against the convention. That's why the books are avoiding it. For your convent, I'm showing again. Don't IB equal to IE. Don't write it. IE will be greater than IB. What is the basic thing? This happens everywhere in the transistor finish over. There's nothing. Agree this one? Okay, I think what is that RF? RF is this one, or for your convenient, I can also show that RF is something like this. Forward resistance offered by base emitter junction. So what is RF? We'll write resistance offered by base emitter junction. This is RF here. So is it justified bringing this one? And what is VB? This potential drop. Barrier potential 0.7 volt. So instead of this PN, better what I should show? Instead of this PN, what we have to show? So the more justified diagram means now you got idea, no? So what most of the teachers we do is like we show students like this. This is RF. This is VBE. Till here, okay. After this, it will become emitter current. This will be more troublesome for you. So what is this? Here IB, here, it gets added up. Collector current will get added up. I'll bring it. Okay, fine. No, you are in no problem. IC plus IB has become IE. So some teachers, what happen to help students to large extent, no, so that they're going like this. Huh? I'm also one of that teacher. I wanted to help you, so I put it. At least now, okay, KVL. No. Look at this. What is this AC signal? What we are doing? Go back to AC circuits. So what we are doing in this branch, we are adding AC signal to DC signal. No? So let's go back to our AC circuit. So if you had this is the DC signal. For this, what happened? I'm adding AC signal. Then the effective signal will become like this. No? Okay, this should be dotted. Huh? For this, we are adding the red color. Oh, this green color is there. We have chosen. Green color is the DC signal. For this, I'm adding AC signal. I think this you have worked out in where? AC circuit. And this is what? VBB. When you add some voltage, so it will fluctuate. So this is what happens to the input voltage at the input circuit. If you remove this V in, okay, constant current will flow. Now, if this overall voltage changes here, so what happened to IB? IB should also change. I'm trying to the main concept I'm trying to bring it here. Without AC signal, what is the current flowing here? Will be constant. Because of AC signal, what happened? Now it will fluctuate, this current. So therefore, what happened? The current will also vary. So I'm going to differentiate this now. Let me differentiate this delta V in, delta VBB minus delta IB, RB plus RF minus delta VB equal to 0. The barrier potential, so it will be fixed. So what are the quantities which will cancel out? This will be a constant. So this delta V in, this will be 0. Barrier potential 0.7. This applied voltage 2 volt. So they are constant here. This constant terms, I'll just highlight it. So finally, what is delta V in? RB plus RF. Keep it equation. Let's come for similarly. If IB varies, what will happen to IC? IC also should vary. Any reason for that? Because what is beta? How you define beta? There's the main concept again. There's a main concept. If this delta beta is a constant. If IB base current varies, then what should happen to collector current should also vary here. So this collector current also is varying. Okay, let's write loop equation for that. So I think concept is over. Almost 99% got over now. Minus ICRC minus VC equal to 0. This is a constant. Okay, let's differentiate. Delta ICRC minus delta VC equals 0. This will be a constant 0. Better write small letter, huh? Because after differentiating, to indicate it's a changing one, equal to 0. So what is VC now? Delta VC is equal to minus of delta ICRC. This is the equation 2. This is what output voltage which we are going to collect. Delta V naught. Delta VC, delta V naught here. How you define voltage gain? Nothing is there. Still like, sir, I don't know working of transistor. Not needed. Sir, I don't know minority carrier, majority carrier. Nothing is needed. Just KCL, KVL here. Okay, now finally, voltage gain will define it. Voltage gain. So this is like a change in output voltage change in input voltage. So this is given by AV is equal to voltage gain AV delta V naught by delta V minus this is delta ICRC plus, so what is this one? Delta V now how much? Delta IB RB plus RF. What is delta IC by delta IB? It should be beta. It should be beta minus of, and next all quantities RC by RF plus, okay, this is I think symbol. Okay, this everything what happened, in fact, what happened to RF? RF will be very small. RF will be very small. So the formula will become RC by RB. Or in the books what happened, they called RC as RL. Because next what we do is we'll connect one load resistance here separately. And how this RC, RL and this output resistance, everything will become parallel. And RL will be less than compared to RC. RC will be less than this resistance across the collector emitter. So therefore, some books they directly wrote this as RL, it justified, and RB they're calling as input resistance. This RB as input resistance. So nothing wrong. That's the same formula. This is RL or output resistance. It is called as, and this is RN. I think there's a more generalized formula where RC is equal to RL. So this is a voltage gain. So now I want the power gain. Let me finish off all these gains. Power gain. Power gain, how you define voltage gain into current gain. What is the voltage gain? Minus beta by RL by RB. I made clear RC equal to RL. So into what is voltage gain? Beta, no? This is called like a voltage gain. Beta is called as voltage gain. So current gain, that is symbol. Output current by input current should be current gain, no? So therefore I'll call it as current gain. So therefore this should be equal to how much? Yeah, this is so minus of a very important formula. You see plenty of numericals just revolves around this. So finally what happened? The power is got amplified. Huh? What is this circuit? The power of a signal is got increased. So more power, more loudness. Go back to sound signal. Intensity depends on what? Power. Okay, that one. The loudness depends on what? Intensity. Intensity depends on what? Power. So greater the power of signal, greater will be the loudness. Agreed? This one? So now let's come back to this about the what we have in a book. So we have a lot of other things which we have to have a clarity here. What is that like? Sir, how that everything gets amplified? Okay, fine, everything you're explaining, everything fine. Okay, we'll do one thing. There's a how that input, what do you mean by negative sign? What do you mean negative sign? So all that will have a clarity. I'll make it small. Let's go for the graphical way of analyzing. This is mathematically I brought it. Same thing, let me put it in through graphs. The input signal, we took it red color. There's the input signal, which is very small. So what is the output signal? Output signal, we are going to there's a positive off cycle, no? So break up this O, A, B, C, D. And during positive off cycle, there's a negative off cycle. I'll write it here. And during positive off cycle, what will happen? As OA increases, see already it is biased, no? You're adding some small input voltage. So for OA, I'll just explain for positive off cycle, it will be enough for you. Huh? Positive off cycle. During OA, what will happen? Forward bias, shall I write FB small? Forward bias across base emitter junction increases. That's all. No? So what is the reason? Already it is forward bias by this battery. When you add some positive voltage for the further, the forward bias will increase. No, go back to the diode. Already it's forward bias. If you further say already it's forward bias, you add some 0.01 node, will increase by a small amount. No, so if the forward bias increases, then what should happen to forward current? Should also increase. Forward bias across base emitter junction increases. Then high B increases. IB will increase. Then we know IC is equal to beta equal to IC by IB. So somewhere here you write it. If base current increases, beta constant collector current should also increase. So IC also increases. Next we have equation what? VC equal to VCC minus ICRC. If collector current increases, this if IC increases, VC constant, RC constant. So what should happen to VC? Should decrease, no? Please analyze here. I want to explain this graph. So what should happen to if IC increases, then VC is constant, this RC is constant. So VC must decrease here. Here what will happen? Therefore, VC decreases. Decreases means what will happen? It should come to the, it should take the values like this. Then till here, this is what OA. Next, from A to B, what will happen? Why they are 180 degree out of phase? Because this negative sign is what I should explain. What is negative sign? 180 degree out of phase. If there's input signal, the output signal will what will happen? The same input signal, it got amplified, but it got inverted. Why that inversion? Already mathematics has shown. I'm explaining using this graphical thing. What actually happens inside the circuit I'm explaining. Okay, got this one? No? VC decreases. So therefore the curve will take like this. So what is V0? V0 or VC? I think most of your confusion. No problem, no? This is okay. Now come for this one. For AB, what happened? The forward bias start decreasing. High B decreases. IC decreases. If IC decreases, BC increases. So from this value starts increasing. So we'll get B. So for OB, forward bias across JB decreases. IB will decrease. So IC decreases. VC increases. And hence AB, so sorry, this is symbol AB. Okay, fine, yeah. A, no, I wrote, I think A only. This is A, OA. Agree with this. So like this, what pen we can explain the curve. So therefore, the input and output signal what pen, there'll be 180 degree out of phase. So how the block diagram for C amplifier, if this is C amplifier, common emitter amplifier, no? If you give small input signal, what it does, it will produce a large output signal. This will stick onto the basic symbols. Then we'll get a large output signal. And what about that? It will be out of phase. Frequency will remain same. Again, please don't think that frequency also change. What was the earlier time period? The same time period. Time period will not change. Only thing is the amplitude has increased. This what C amplifier. So what is the output signal will be amplified, but will be 180 degree out of phase compared to input signal. Agreed? No. So this is a story finish over now. Anybody asks, okay, power gain, voltage gain, you have a formula. If I plot a graph, okay, let's do one thing. This particular signal is having a frequency, no, f equal to 1 by t. What is this f? Frequency of AC signal. Sir, what is frequency of AC signal? I am speaking. Tell me what are the range of frequencies will come. It will be of audio frequency, 20 Hz to 20 kilohertz. Okay, that one. So now I'm going to vary the frequency. Let's see that how this amplifier response will come. When I check this, the graph is of this kind. This is the frequency. This is a voltage gain. I'm plotting voltage gain versus frequency. What do we have here? Voltage gain. Look at now. So what are this? These are lower frequencies. So now we'll categorize ourselves like this. These are the lower frequencies. These are higher frequencies. And these are middle range frequencies. So where the gain is maximum, for middle range frequencies, gain is maximum. Okay, now we have to give reason this also. And these are low range frequencies. These are high range. Now come out of that audio, something I gave example. Like this, it's not that only amplifier, even what happened in mobile, the signal will be very weak. The mobile output should amplify and give it to the mobile circuit inside. So it's not that only audio amplifiers will be there. Radio frequency amplifier, micro frequency amplifier, different for signals frequency will be there. Now this circuit, when I plot for different frequency, I do get. Now why the gain is very less for low range? Okay, again you go back to RLC circuit. What we think? What we think here? What do we think? This one, there's no capacitor. In fact, a capacitor there I didn't introduce to confuse you. What happened? I didn't introduce here. There'll be a capacitor there. So here, so from where that capacitor will come, the you are going to introduce one capacitor. Along with that, what happen? This junction, collector base emitter junction, will act like a capacitor. It will be like a dielectric slab, collector base and dielectric slab. Then this connecting wire will have capacitance, will have inductance. So here what actually you'll get it along with the resistor cell, this one, you'll also get what? One inductor, capacitor, everything you have to bring. So, but I am not saying capacitor inductor. Any current carrying structure will have inductance. Any what will happen? Any current carrying wire will have capacitance. So capacitance, inductance, and moreover the AC signal. So what do we expect? Reactance will come. So now at low frequencies, which reactance will dominate? Capacitive reactance. Okay, because of capacitive reactance, this is very less. Okay, got this one. Everything else, so many things are there. This one again next year. At this frequency, what happen? At particular frequency, what happen? The capacitive and inductive reactance will almost nullify. We are having gain more. Why again reactance is, why gain is less? Here what happen? The inductive reactance will dominate here. Here what happen? The reactance of circuit will be minimum. That's why the gain is more. So therefore, if I'm using amplifier, I should operate in this region. I should not operate here because I'll get a gain less. So the amplifier what I used to use in class, no, it will be designed to operate here. But sir, means now you can question, so it will amplify all signals. Okay, now I'll design the circuit so that it should operate here. I think for your level, I think if you can just remember how the gain varies with frequency. First increases, becomes maximum, almost remains constant, then decreases. For middle range frequency, reactance is minimum. Here, capacitive reactance, inductive reactance,